Okay, today we'll be talking about graphing parent functions and performing transformations with them. So there was a page to print out, paste in your notebook, or to copy this into your notes, page 6 on parent functions. Here they are all listed with certain things about them. So we have an identity function here, we have cubing function, we have a constant function, which is a horizontal line, and a cube root function, different properties of domain range, your x and y intercepts, and if it's an odd, even, or neither graph. So good idea to put this in your notes. Moving on, we have our square function, our parabola. We have our absolute value, which is that v. We have our square root function, and we have a reciprocal function here. All right, now let's talk about transformations. This again is in your notebook, in a PDF document. I believe it's on page 5. So we have 6 different ones we're actually going to cover. The other ones I'm going to show you we don't need to know for this year. So we have a vertical translation up. So that means if my plus a number or minus a number here is on the outside of the function. So for the one on the left, they're going x squared plus 2, so they're going up 2 units. So they're taking the x squared graph and they're going up 2 units here. And this is where the new transform graph lands. For minus k, here they're taking the square root function, which kind of looks like a hook. They are going minus 1, so they're going down 1. So here they're going down 1 from the original one. So here's the transform graph for that one. We have now going left and right, which is the opposite of what you think here. So here, when it's inside the function, not on the outside like the up and down, inside the function, if it's minus h, it's to the right side. We're going to the right. If it's plus h, we're going to the left. So for the translation right example, they're asking us to plot the absolute value of x minus 2. So that means we're going to the right 2 units. So we're going this way, right 2 units, and this is where it lands. For the translation left, they're using the x squared function, and they have it as x plus 2 squared. So that means we're going to the left 2 units, and this is where it lands. Okay, moving on. We have reflection over the x-axis, reflection over the y-axis. Reflection over the x-axis is where the negation is in front of it, in front here. So I'm doing the square root of x graph, and they reflecting it over the x-axis. The negative's in the front. This is where it lands, completely flipped over the x-axis. If I am doing the reflection over the y-axis, the negation has to be inside the function here. So if I'm going to reflect the square root of x in the y-axis, the negative is going to be inside the square root, and they reflect it over the y. Here's where it lands. The other 4 that are below on the PDF for stretching and shrinking, you don't need to know those for this year. All right, moving on. We have a last document there in the weekly planner. We're going to be doing 1 to 4 in class, and then you guys are going to be doing, I think, the rest for homework. So when I ask you to graph a transformation, I want you to graph the parent function first, have at least 3 points, and then use those 3 points to move. So let's take a look at this equation. X minus 2 squared plus 4. What kind of transformation is going on here? So we have minus 2 on the inside. So that means we're going to the right 2 units. And then it has a plus 4 on the outside of the function. That means we're going up 4 units. So those are the 2 movements we're going to be doing. What is the parent function here? The parent function is an x squared graph. Now, you should be able to know specific points for an x squared graph. Let's say you did not. I would just set up a chart like this, x, substitute it in your equation, and get your output. So I'm going to use a negative, a 0, and a positive, and I'm going to plug those in. This is 1, so I'm going to plot negative 1, 1, 0 squared is 0. I'm going to plot 0, comma 0. And for the last one, 1 squared is 1. I'm going to plot 1, comma 1. Let's go ahead and plot those 3 points as best we can. Here, here, and here. Now I connect them. All right. Now let's go ahead and do our transforming graph. So now I'm going to take those 3 points that I did in black, and I'm going to move them right 2, up 4. So right 2, up 4. So the one here at the origin, right 2, up 4, is going to land right here. Let's do the other one, right 2, up 4. Right 2, up 4. So the one in red is my transform graph. All right, we need domain and range of the red graph, the transform graph. The domain is your input, your x's. Well, I have all possible x's because the width could get wider and wider as it goes up. So my domain is going to be negative infinity to positive infinity. My range, though, is going to be kind of picky. It can't go below this 4 here, right? So my range is going to have a bracket 4. And it's going to go all the way up positive infinity for all those positive numbers above. All right, let's take a look at example 2. Here's a square root graph. It's the square root of x plus 1 plus 4. All right, let's talk about the transformation. We have plus 1 on the inside. That means it's going to be going to the left 1 unit. And then on the outside is plus 4. That means it's going up 4 units. All right, this is the movement we're going to be doing. What is the parent function? It is square root of x. All right, let's get some points here for square root of x. I want to have perfect square numbers. So I'm going to choose 0, 1, and 4. Square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. These are the 3 points I'm going to plot. So let's go ahead and do that. 0, 0, 1, 1, 4, comma 2. All right, here's my parent function. So now I'm going to do in a different color. All right, let's do blue. We're going to go left 1 unit, up 4 units. So left 1 and up 4. Left 1 and up 4. Left 1 and up 4. So this is my transform graph, the one in blue. Let's get the domain and range. All right, this domain is definitely restricted. The lowest x I see here is at -1 with a bracket to positive infinity. The range, the lowest for the y, is at 4, bracket, positive infinity. Okay, let's take a look at number 3. We have absolute value now of x minus 3 minus 2. Okay, what kind of transformation is this? With the minus inside, that means it's going to go right 3. And then the minus 2 on the outside means it's going to be going down 2. So those are the 2 movements we're going to use for this one. What's the parent function? It's the absolute value of x. Absolute value of x is real easy. Whatever you input, right, you always get a positive answer back. So if I input -1, I'm going to get 1 back. 0 and 1, 0, 0, 1, comma 1. So it's basically making a V shape. So this one, and this one. Okay, and now we extend it. All right, there's my parent function graph. Now let's go ahead, let's do it in green. Let's do this movement, right 3, down 2. So going to the right 3, down 2, landing here, and landing here. All right, the one in green is our transform graph. Let's talk about domain. All possible x's. Well, it looks like it's negative infinity to infinity. Range is does have a low y value. It looks like it's at -2 with a bracket to positive infinity. All right, last example, number 4. This one has 3 different things going on here. So we have our plus 5 on the inside. So that means going to the left 5. It has a minus 1 on the outside. That means down 1. And now a little extra here is we have this negative in front. That means it's going to be reflected the x-axis. So whenever you have a reflection with other transformations going on, you always want to start with the reflection first. Do that first, then do the left and down movement. All right, what is the parent function? The parent function is x squared. We did that for the first problem, so I'm not going to read you the point. We do the whole chart there. So it was negative 1, 1, 0, 0, 1, comma 1. Okay, here is my parent function graph. All right, now let's do the transformation. So first I'm going to reflect things in the x-axis. So if I reflect 0, 0 in the x-axis, it's going to stay at 0, 0. And now I'm going to go left 5 and then down 1. Now I'm going to reflect negative 1, 1 in the x-axis. It's going to land here, right? But I got to move that left 5 down 1, so it's actually landing right here. Whoops. Let's redo that one. Okay, next one is, again, reflecting 1, comma 1 in the x-axis, so it would land here, right? But I got to go left 5, down 1, it's landing here. So here is my transformed graph in red. What's the domain of this one? Well, it's going to get wider as it goes down, so we got negative infinity to positive infinity. Let's see, what's my biggest y value? It's at negative 1. So bracket negative 1, and it goes down to negative infinity there for the range.